Okay, scientific notation and division. Please keep in mind that given scientific notation, we're going to have our final answer will come out A times 10 to the nth power, where A is greater than or equal to 1 but less than 10, and n is equal to some integer. Okay? So an integer. So let's take a look at this. Here we have 1.5 over 3.0, which is 0.5, right? 1/2, right? This is 1/2, isn't it? So this is 1/2, and we know that 1/2, I'm using this piece right here. This is 1/2, isn't it? So 1/2 is equal to 0.5, so 0.5. And then we look at this piece, and we know that we have x to the m over x to the n is equal to x to the m minus n. So we're just going to use, we're going to just use that little fact that we know and do 10, because they're both base 10, to the negative 7 minus 4, which is equal to 10 to the negative 11th power, right? So we get 10 to the negative 11th power. But when we test this value here for A, we put in 0.5 here. We ask ourselves, is 0.5 greater than or equal to 1? And it's not. So we have to increase it 10 times. So we're going to move this 10 times. So we're going to make this 10 times bigger. So it's going to be 5 times 10. We're going to make this bigger. So with a negative x, when the closer it gets here, this will be 10 to the negative 10. All right? People get really confused about that. This is all we're doing. I'm saying this to you. All right, so let's do this problem first, and then I'll go back and show you where my logic is. Please keep in mind again that this is where we are. We're stuck at this piece right here, aren't we? So let's go ahead and do this piece of work here. And we have 3 over 8, and 3 over 8 is equal to 0.375 times, and then I'm going to look at this. And I'm going to do this. I'm going to do 10 to the 7 minus, right? Because formulaically, we know this is the rule. It's x to the m minus. So this first negative sign is the one from the formula. However, we also have negative 6, right? So we have, this is our negative 6. So when we do that, we end up with, all right, negative is a positive, so we get 10 to the 13th power. So 10 to the 13th power. However, 0.375, I'm just going to do the same thing I did on the last problem. 0.375 is greater than or equal to 1 and less than 10. I'm sorry, and less than 10. Well, it's certainly less than 10, but it is not greater than or equal to 1. So this isn't true, so we have to adjust until it is, and we move it over and we get 3.75. Well, that, we made our number 10 times bigger, right? 0.375 times 10 is 3.75. So we have to make this number 10 times smaller, which would make it 10 to the 12th power. Remembering that 10 to the 13th is 10 times 10 times 10, 13 times. So to make it 10 times smaller, we would just take away one of those factors of 10. Okay, here's my explanation of this whole thing. So here's our final answer here. And where in the world is our, and here's our final answer here. All right? This is my explanation of this. Let's say we have some number A times some number B. Well, that is certainly the same as AB, isn't it? And all I'm saying to you is this. If I made this number 10 times bigger, so I said 10 times A, but I wanted the answer to still be AB, I would have to multiply B times 1/10. Remembering that multiplication is commutative, I could take this 10 here, times this 1/10 here, 1/10 here, times A times B, and 10 times 1/10 is 10 over 10 is 1, and 1 times A is A, and A times A is AB. This may be a little bit confusing, and I don't mean to make it overly confusing, but this is very doable, and I think what will really help us the most is to just do a ton of reps on this. So please don't give up on this. I'd love to hear your comments. If you haven't already subscribed, please do.